Good morning, students. We are going to continue with the same chapter, that is chapter 2, motion in one dimension in physics. Now, we already dealt with many graphs like displacement time graph, velocity time graph. Today we'll be studying about acceleration time graph, and we'll be discussing about the motion of a body under gravity. Motion of a body under gravity means a freely falling body. That is, when you drop any body from some height, it falls freely towards the ground. That is called the motion under gravity. And we have already seen that such motion always has a uniform acceleration, a constant acceleration. That is, when a body falls freely under the action of gravity, it falls with an acceleration of 9.8 meter per second square or 10 meter per second square. So we are going to see the graph, that is acceleration time graph for such motion, that is the motion of a body under gravity. The case for the acceleration time, one side I have taken time from 1 to 5 seconds. The other side is the acceleration. For each second you can see the acceleration is same, which is 10 meter per second square. Now when we plot the acceleration versus time in the acceleration time graph, let us see what kind of graph we get. So you can see after 1 second the acceleration is 10 meter per second square. After 2 seconds the acceleration is same, that is 10 meter per second square. So till 5 seconds the acceleration remains same. So when you draw or join these points, you will get a line parallel to the time axis. And this is what the graph for acceleration time graph is. It will be the line parallel to the time axis. Now using this acceleration time graph, we can find the displacement, the velocity of a body. And we can also draw the displacement time graph and the velocity time graph using acceleration time graph. Let us see. From this graph we can first find the velocity after each second. In order to find out the velocity, the process is same. You have to find out the area of the enclosed figure. Let us see what velocity will be for a body at the end of 1 second. You can see the graph here is, or the figure here is a rectangle. On finding the area of the rectangle, we can find the velocity of a body after 1 second, which I have shown here. Velocity of a body after 1 second, since that is rectangle, you can consider this as the length and this as the breadth. So length is 10, breadth is 1, velocity is 10 meter per second. Velocity after 2 seconds, you can join this line. Now you can consider this as the rectangle where the length is 10 and breadth is 2. So we are getting 20 meter per second. Similarly, at the end of 3 seconds, the length remains the same 10 and the breadth will be 3. That means it becomes 30. Similarly, for 4 seconds, it is 40 meter per second. At the end of 5 seconds, the velocity is 50 meter per second. Now let us try to draw the graph for this data, that is the velocity time graph. We can now mark the points. After 1 second, the velocity is 10 meter per second. So we can have one point here. After 2 seconds, the velocity is 20 meter per second. We can have one point over here. Similarly, for 30 meter per second, this is for 40 meter per second, and at the end of 5, we can see it is 50 meter per second. Now when you draw or join all these points, you will get a slope. This graph is called the slope, and this is how we can find the velocity using the acceleration time graph, and also we can plot acceleration time velocity time graph using the acceleration time graph. Okay, so since we have already drawn the velocity time graph, from the acceleration time graph we have already seen, and using this velocity time graph we can find the displacement for each time. Let us see how. First of all, we can find the displacement after 1 second. You already know, to find the displacement from the velocity time graph you have to make a figure, and area of that figure will be the displacement. We can draw one line here. You can see we got a rectangle. So for displacement after 1 second, it's not a rectangle, sorry, it is a triangle. So the displacement after 1 second can be half into base into height. So here base is 1 and height is 10. So we got 5 meter as the distance covered. After 1 second the displacement is 5 meter. Now you can see the displacement after 2 seconds. You can draw one line. You got another triangle here, where you can use the formula half into base into height. So again you can draw one line here to get the displacement after 2 seconds. You got a triangle. You can see this triangle we have got. Again you can apply the same formula. This will be the base. So half into 2, which is the base here, and height is 20. So we are getting 20 meter as the displacement. Similarly, after 3 seconds the displacement will be on finding out the area of another triangle. Here the base is 3, height is 30, we are getting 45 meter. Same way the displacement after 4 seconds will be 80 meter. Displacement after 5 seconds will be 125 meter. Now let us see, using this displacement time, how can we plot the displacement time graph and what kind of graph we are getting. Okay, so here we have the displacement time graph. Let us see what kind of graph we'll be getting on plotting displacement against the time. We can see displacement after 1 second is 5 meter. This is 1 second, and we can assume 5 meter over here. Since the interval you can see it is from 0 to 20, so 5 meter can be taken here. So this will be the first point. After 2 seconds the displacement is 20, so we can plot one point here. After 3 seconds you can see the displacement is 45. We can, if this is 50 mark, then 45 can be somewhere here. So we can consider this as the 45 meter. Then after 4 seconds the displacement is 80 meter. 4 seconds and this will be 80 meter. And after 5 seconds the displacement is 125. After 5 seconds the displacement can be 125. So these are the different points we have got. Now let us see what kind of graph we are getting on joining these points. So on joining the points we can see we are getting a curved line. And this curved type of graph is called parabola. This type of curved graph is called parabola. So we have seen how can displacement time graph be made using the velocity time graph. So from acceleration time graph we can obtain velocity time graph. We can also obtain displacement time graph. So we have already seen the displacement against time. Let us see, after 1 second the displacement we calculated was 5 meter. After 2 seconds 20 meter, and at the end of 5 seconds we calculated the displacement as 125 meter. Now there is one relation, that displacement is directly proportional to square of the time. When you take the square of this time, and let us see how using this square of time we get different displacement. So square of 1 will be 1 itself, square of 2 will be 4, 3 will be 9, square of 4 will be 16, square of 5 will be 25. Now since it is displacement is directly proportional to square of time, so same number of times the displacement will also vary by. So here displacement after 1 second is 5. Now when you are making the square of 2, that is it becomes square of 2 means 4. So 5 into 4 jar displacement will be 20. The square of 3 will be 9. So 5 9 jar 45. Square of 4 will be 16. 16 5 jar 80. Similarly, square of 5 is 25. 25 into 5 jar 125. So starting with the same displacement, using the square of the time, you can find the displacement of a body accordingly. Now we are going to plot the displacement against the square of time to find out the graph. So we will be using this data. At the end of 1 second, we will be considering this as 1 second and the displacement as 5 meter, because you can see the interval is 0 to 5. So somewhere here we can take as 1 second. So this is the first point we got. At the end of 4 seconds, the displacement is 20. So this is 5. So just near to it will be 4. Displacement will be 20. We can consider this point. For 9, displacement is 45. This point can be taken as 9 seconds. Displacement will be 45 here. Then at the end of 16 seconds, displacement is 80. Similarly, at the end of 25 seconds, the displacement is 125. Now, what kind of graph we'll be getting on joining these points? Let us find out. For this, you have to join all these points. On joining these points, you can see the graph is a slope. And slope itself indicates that the displacement is directly proportional to the square of the time. And this way, we have calculated the displacement time graph, and many other things also we calculated using various graphs, and we have completed this chapter. Not this chapter fully, but this section we have completed, and next will be the question answer that I will be giving you. I will be dictating all the answers also. You have to listen to all those answers carefully, and wherever drawings are required, I will draw the graph and send to you. Till then, thank you.